Hey everyone, since we don't have time to go over the quiz in class, I'm gonna make little videos with the solutions and I hope that helps you guys. So the first one was limit as h goes to 0 of this quantity. So if you just input h is 0, you'll see that you get 0 over 0, so you have to do something to it. You can't just plug in h equals 0. So what we're gonna do, we're just gonna calculate this quantity. So this is gonna turn into limit as h goes to 0. Negative 5 plus h squared is going to be negative 5 squared plus 2 times the first times the second plus h squared minus 25 over h. And this equals limit as h goes to 0 of 25 minus 10h plus h squared minus 25, everything over h. You notice that this cancels, and then we can also factor out an h. So what we're going to have left is negative 10 plus an h over h, and then the h's go away, and as we let h go to 0, I'm going to have negative 10 plus 0, so the answer will be negative 10. Okay, for the next one, you had limit as x goes to 2. Again, we have to work it out a little bit. We can just plug in 2. So what we're going to do is factor the denominator of the second one. So x squared minus 4 is x minus 2x plus 2. And then we need to bring them to the same denominator, so I need to multiply this by x plus 2. X plus 2. So then we have limit as x goes to 2. The common denominator now is x minus 2 times x plus 2. And then at the top in here I have x plus 2 and then the minus 4. And let's see where that takes us. Limit as x goes to 2. X plus 2 minus 4 is x minus 2. And you'll see that that's going to cancel now. So then the limit becomes limit as x goes to 2 of 1 over x plus 2. And now we can simply let x go to 2, and this becomes 1/4. Okay, now for the last problem. Since we have to determine the values a and b such that the function is continuous, this means that we must have that limit as x goes to 2 from the left of our function f of x has to be equal to the limit as x goes to 2 from the right of f of x, and it has to agree with the function value at 2, f of 2. Notice that f of 2 is 3 from here, right? When x is 2, the function is 3. So let's calculate the limit as x goes to 2 from the left. As x goes to 2 from the left, it's this one, so we'll use b minus ax squared. So this becomes limit as x goes to 2 minus b minus ax squared. And if we simply let x go to 2, this gives us b minus 2 squared is 4, so b minus 4a. Alright, so now let's look at limit as x goes to 2 from the right. And then from the right is this one. So this will be limit as x goes to 2 plus the function now is a plus bx. As we're letting x go to 2, this becomes a plus 2b. Okay, so since the left one has to agree with f of 2, which is 3, that means we're going to get that b minus 4a has to equal to 3. And then also the right limit has to equal to 3. So a plus 2b also has to be equal to 3. So now we have to solve this system of equations. You can solve it by substitution or by elimination. So let's solve it by elimination. So I want to eliminate a, so I'm going to multiply this by 4, and I'll leave the first one as it is. So I'm going to have b minus 4a equals 3, and then I'll have 4a plus 8b. So let me write the 8b in here, and then the plus 4a equals 12. And now I'm going to add these two. So I'll get 9b, the a's cancel, equals 15. So b equals 15 over 9. And if I reduce it by 3, I get 5/3. So b is 5/3. And now we're going to go back and plug in b in one of the equations and get a. So let's go into the first one. So I'm going to go into the first one. So instead of b, I have 5/3 minus 4a equals 3. So I'm going to subtract 5/3. So I have negative 4a equals 3 minus 5/3. So negative 4a equals, I need to bring to the same denominator, so let's multiply by 3 over 3. So I'll have 9/3 minus 5/3 minus 4a equals 4/3. Divide by negative 4. I get that a equals 4/3 times 1 over negative 1/4. So a equals negative 1/3. Okay, so we have both. So when a equals negative 1/3 and b equals 5/3, the function is continuous at 2. And that's what we needed to find, right? It says determine the values of a and b such that the function is continuous at 2. Alright, I hope that helped.